Okay, so this is part 2 of the indefinite integral. So, for example, suppose we are given that dy dx equals x squared times the square root of y, where y is greater than 0. And we want to find a function, a general solution, whose derivative is this. So we need to separate and integrate. And what you could think of is putting this over 1 and cross multiplying to where you get dy equals x squared times the square root of y dx. So this times that and this times that. You now need the y's with the y's and the x's with the x's. So since this is all multiplied, you can divide by root y and get dy over root y equals x squared dx. Now that we have separated the y's with the y's, the x's with the x's, we can integrate. Now we only have one form of integrating, and that is x to the nth power. So I'm going to rewrite this as y to the negative 1/2 dy equals x squared dx. Now I can increase the power by 1, so I'll add 2 over 2, and 2 over 2 minus 1/2 is 1/2. To divide by 1/2 means to multiply by its reciprocal, which is 2, equals x cubed over 3 plus c. Because when I increase the power here by 1, I get 3, and I need to divide by that new power. Now, at this point, if I were given points like suppose 1, 1, and I want to find the particular solution, I would put them in here now. But I'm not given those points, so I'm just going to solve for y. I'm going to multiply through by 1/2 and get y to the 1/2 equals 1/6 x cubed plus 1/2 c. And then I will undo the 1/2 by squaring both sides, and the general solution will look like y equals 1/6 x cubed plus 1/2 c squared. And you could leave it of that form, or you can call this a whole new constant d or c1. Okay, but the whole point being is that this term here is a constant. You can keep it as 1/2 c or call it a whole new constant d. If, though, you are given x is 1 and y is 1, that means we can go for the particular solution. So you would have replaced x with 1, y with 1, solve for c, put that value back in here. So let's do that. Let's suppose that were the case. And you would have 2 root y equals x over 3, well, x to the third over 3 plus c. X is 1, y is 1. So you'd get 2 equals 1/3 plus c. Subtract a third, and 6 minus 1 is there, 5/3 is c. So c would now be 5/3. I put this back in and get that. Multiply through by 1/2 to get root y equals 1/6 x cubed plus 5/6. And then I would square both sides to learn that the particular solution is the function 1/6 x to the third plus 5/6 squared. And you can see if you're right, because if x is 1, you get 1/6 plus 5/6 is 6/6, which is 1. And 1 squared is 1, and you need to get back that y value. So you can always see if you're correct. All right? So just some more examples. Let's see what else we've got here. What else is there? So suppose we have the slope along a curve. Slope is dy dx equals 4 over 3 root of y. Very important example, okay? We need to separate. So think of cross multiplying and get 3 root of y dy equals 4 dx. Get the y's with the y's, the x's with the x's, okay? It is often better to keep the constant over here. So I'm going to have root y dy equals 4/3 dx. Get the constant over here. It's often easier that way. Now that I've got the y's with the y's and the constant over here with the x, even though there is no x, I put the constant over there, I'm going to integrate. Separate and integrate. Separate the variables and then integrate. This is y to the 1/2, so I'm going to increase the power by 1 and get y to the 3/2 multiplied by 2/3, it's reciprocal, equals 4/3 x plus c. If I'm given an initial value, it is at this time I would put in the value for x and y and resolve for c. But being that I don't, I'm just going to multiply through by 3/2, multiply everything through by 3/2, and I get y to the 3/2 equals, these would drop out, 4 divided by 2 is 2, that'd be 2x plus 3/2 c. You undo the power of 3/2 by the 2/3, so the general solution would look like this. You can call this right here a whole new constant, d, if you wanted to, or c1. But that would be the general solution to this differential equation. We could find the particular if we were given an initial value. All right. Next. Let's take a look. Suppose I am given dy dt equals 2 minus t, and y at 1 equals -2. So I'm going to separate, integrate, put this over 1, and picture cross multiplying. But this needs to be in parentheses, because it's dt times this whole side. And really, again, you can multiply each side by dt, and by the chain rule, you'd get that dy equals 2 minus t dt. Now that I've separated, I'm going to integrate. And the antiderivative of dy is y equals 2t minus t squared over 2 plus c. T is 1 and y is -2. So y is -2, because that's what y is, and t is 1. So it'd be 2 minus 1/2 plus c. That's 4 minus 1 is 3/2. Subtract the 3/2, so -2 minus 3/2 equals c. -4 minus 3 is -7/2 is c. So c seems to be -7/2. If I did everything here correctly, this is 2t, yes, and t is 1. I just want to double check. So this is y, 2t minus t squared over 2 plus c. T is 1, 2 minus 1/2 is 3/2 plus c. And then subtract the 3/2 over, we get -7/2. So then now this would become, the particular solution would become this. And there's a way to check to see if we're correct. We can put 1 in for t and get 2 minus 1/2 minus 7/2. And we better get out -2 for y. So -8/2, -8 over 2, would become -8 over 2, which would be 4, and 2 minus 4 is -2, so that is correct. Okay? What else is there here? What else is there? Okay, and I had the velocity problem as the last one. So suppose the velocity of an object, v at t, equals 6t squared minus t plus 1. S equals 3 at t equals 1. Find S of 2. So that means we've got to find the position function, okay, when at t equals 1, the position of the particle is 3. So this translates into a point of S at 1 equals 3. That's going to enable me to find the particular position function. It's the initial condition. So the antiderivative of velocity is position. So S of t equals, increase the powers all by 1, and we should put a dt here. So t cubed over 3 would be 2t cubed minus t squared over 2 plus t plus c. Okay? You could have called v at t ds dt, because that is the same thing, just to be quick. And then you multiply each side by dt, or cross multiply, and ds equals 6t squared minus 6t plus 1 times dt. Now that you separated, integrate, and the antiderivative of ds is s, position. Or simply the antiderivative of velocity is position. So now I have to solve for c. And what I will do is substitute when t is 1. So I'll get 2 minus a half plus 1 plus c. And s is 3, so that means this is 3. So 2 plus 1 is 3. 3 minus a half, that's 6 minus 1 is 5 halves. So 3 equals 5 halves plus c. Subtract the 5 halves. 3 minus 5 halves is c. 6 minus 5 is 1. So c is 1 half. So that means now the particular position function is now this. So the particular position function is this. I can find s at 2 by replacing t with 2. 2 squared is 4 over 2 is 2. 2 cubed is 8 times this is 16. This is gone, plus a half. 32 and 1 is 33 halves. So that means that the position of the particle at time t equals 2 is 16 and a half units, or 33 over 2. But the point being is that we're now going backwards, and that the antiderivative of velocity is position. Increase the power by 1, divide by the new power. We've obtained the general position function, and then when you use the initial value where t is 1 and the position is 3, we can learn what c is, which gives us the particular position function, which means we can find the position of the particle at any time t by replacing t with that value. So at time t equals 2, we got 16 and a half. And remember, anytime you're told in these problems, the slope along the curve is dy dx. Separate and then integrate. And how do you separate? So like look here in this important example, this comes up quite a bit. Suppose dy dx equals 3xy. Okay? Very important. Leave the constant there. So separate like this. Okay? Separate. Leave the constant there. You can get the y over here by dividing. You can never add or subtract in these. They're only separable if x's and y's are multiplied. These are all multiplied. So we can only separate through division. So I'm going to divide by y, and let's make that a y squared. Otherwise it won't work. So I divided by y squared. Leave the constant here. Now that I've separated, integrate. This has to be x to the nth, so make it y to the negative second. When you increase it by 1, you get y to the negative first. Divide by the negative equals 3/2 x squared plus c. Remember not to evaluate any negative exponents. So make that negative 1 over y equals 3/2 x squared plus c. Okay? Because when you increase that power by 1, you get negative 1, divide by the new power. Increase it by 1, which is 2, divide by the new power. And then, you know, whatever c is, or whatever the particular point is, maybe it's 1, 2. If x is 1 and y is 2, so then I'd get negative 1/2 equals 3/2 plus c. Subtract the 3/2, get negative 4/2, and c is negative 2. Now the algebra can get a little tricky here once c becomes negative 2. So negative 1 over y equals 3/2 x squared. What did I say? Minus 2 that becomes? Because that's negative 4/2. When y is 2, that's negative 2 is c. So then now I would divide out the negative by changing all signs to their opposites. So I get 1 over y equals negative 3/2 x squared plus 2. It's a fractional equation. Multiply everything through by y. And then I would get 1 equals negative 3/2 x squared plus 2 times y. Divide. So then finally, y would be equal to negative 1 over negative 3/2 x squared plus 2. And remember, we can always check to see if we're correct. So if y is 1, and if x is 1, we should get out 2. So this is now negative 3/2, correct? Plus 2 over 1. So that is going to be negative 3 plus 4 over 2 is 1/2. But now that seems to be that. Did I divide the negative out? This looks like it should have been negative. Yes, I didn't divide that out. No, I did. Because this was a negative 2 right there. So this was a negative 2. So when I divided the negative out, this is a positive negative. Negative. When I divided the negative out, c was negative 2. And then now I'm going to divide the negative out. Okay. So I got, let me backpedal. I got negative 1 over y equals 3/2 x squared plus c. It's at the point 1 and 2. Trying to erase, I'm losing some of my work. When x is 1, I get 3/2, subtract it, and y is 2, I get negative 1/2 minus 3/2 is c. That's negative 4 over 2, which is negative 2. So c is negative 2. Okay. Divide the negative out, and I get 1 over y is negative 3/2 x squared plus 2. Multiply each side by y, and then divide, and I would get 1 over negative 3/2 x squared plus 2 is equal to y, so no negative. Okay, so then I took it the step before, because when I divide the negative out, I get positive 1 over y equals negative 3/2 x squared plus 2. Replace the x with 1, and now I get negative 3/2 plus 2. Negative 3 plus 4 is 1/2. So when I invert and multiply, I get 2. So you saw before that when I had checked it, I wasn't getting positive 2. And that's a good thing. So it made me realize I had a mistake somewhere in signs. And where I had the mistake was I guess I was looking at the wrong equation when I run the negative sign through. So now I realize that the correct solution is positive 1 over this, which would be equal to y, the particular solution. So again, be very careful about when you have the constant here. It's easier to keep it on the right-hand side. Cross multiply and then divide, keeping the constant on the right. Hope that helps.